I'm Helen Flynn, the first author of the paper Baseflow from Snow and Rain in Mountain Watersheds. The primary objective of this work was to compare baseflow, peak sweep, precipitation during melt, and summer precipitation in 12 snow-dominated catchments in Colorado over a 40-year period. This hydrograph demonstrates the progression of streamflow throughout the year in these catchments. When winter snowpack begins to melt, we see large peak flows in the spring, which later decrease after the snow has melted out and become baseflow. We calculated baseflow using flow duration curves, but also proposed the use of a melt year. The melt year is defined from the onset of melt in the spring to the next onset of melt the following spring. This approach allows us to use flow duration curves to derive baseflow with values from the same melt season. We correlated melt year baseflow values with peak sweep, precipitation during melt, and summer precipitation. We also used multivariate regressions to make this comparison. In both instances, peak sweep and summer rain showed higher correlations with the melt year derived baseflow. Finally, we correlated peak sweep and melt year baseflow with lags of up to 5 years for high snow years and low snow years separately. Baseflow immediately following a low snow year showed the highest correlation. In summary, the melt year baseflow is different from the water year derived baseflow. Melt year baseflow values are more representative of the processes occurring in these watersheds. Peak sweep and summer precipitation dictate baseflow, especially in the larger basins. And finally, lags between peak sweep and baseflow are best identified when separating low snow and high snow years.